I have no clue how many of you have pondered over it. We have just kept the board as it is, as I left in the last class. So, I am written that this is the last lecture on portfolio optimization, which it is. Now, if you have not pondered over it, let us see how to really draw such diagrams. The first good thing, okay, here the parameterization, I think I made a little mistake. I will just go ahead and do the parameterization again. I will just go by Roman's books. So, if you anybody sees the books, it will be much more easier for them. It is just they have taken W1 to be 1 minus S and they have taken W2 to be S. So, in that sense, mu has become 1 minus S mu 1 plus S mu 2, and this has become, it is just a shift switch, is nothing. Only then the things would be slightly different, you have to change, because basically we want mu 2 to be bigger than mu 1, that is when we draw the diagram, that is the reason for all this change. So, it will become 1 minus S sigma 1 plus minus S sigma 2. So, how we are going to draw the diagram? So, first trick is just consider this parametric equation 1 minus S mu 1 plus S mu 2. Just consider this, do not bother about 1 minus S plus minus S sigma 2. So, now take this diagram sigma dash and mu. So, suppose you have these 2 points mu 1 sigma 1 and mu 2 sigma 2. First consider the plus case. First consider this set mu equal to 1 minus S mu 1 plus S mu 2, and that is why. So, if you consider the plus case in sigma dash, sorry, it is sigma 1 plus minus. So, if you consider the plus case, what does this represent actually? What is mu sigma? If you look at it very carefully, mu sigma is nothing but 1 minus S mu 1 sigma 1 plus S mu 2 sigma 2. So, it is the line segment or a line passing through mu 1 sigma 1 and mu 2 sigma 2. So, basically this is showing 2 different assets with their. So, this is just a line passing through mu 2 sigma 2 and sorry, in this case we are always keeping mu 2 as higher. So, here is the line segment joining mu 2 and sigma 2. Now, if I have the minus 1, that is sigma dash, I have the same mu, but sigma dash is 1 minus S sigma 2, 1 minus. So, then it is nothing but the same thing. I should draw it in a better position. So, it is the same thing, but this time it is a line passing through mu 2 minus sigma 2 and mu 1 sigma 1, that is what is happening. So, it is passing through mu 2 minus sigma 2 and mu 1 minus sigma 1, right. So, that is exactly what is happening. So, now it is just the reverse. So, here if I have the diagram, so here if I had the same mu 1 sigma 1, so now it is a line passing through mu 2 but minus sigma 2. So, whatever was sigma 2 there here, so I have to have minus sigma 2 here. So, it will be same mu 2, but minus sigma 2. So, it will be the, so it is mu 2 minus sigma 2. So, it will come here. So, here I am drawing this. So, this point will be the same mu 2, but minus sigma 2. Because here you basically then in this particular case you have mu sigma represented as 1 minus s mu 1 sigma 1. That is, if you, what is happening, if you put s equal to 0, it is giving me mu 1 sigma 1, it is s equal to 1, it is giving me mu 2 sigma 2. So, when you move from 0 to 1, you go from here to here. So, it will become plus s into mu 2 minus sigma 2. That is what is happening. So, here I have this, we are joining this line. But when you take the mod, everything is positive. So, what will you do? You will reflect this line along the x axis. In this case, when it is plus, what will you do? You will have to reflect this part along the mu axis. If you reflect it, it will come this side. So, basically then you forget this part and you really concentrate on this part. Here also you will have a reflection, but reflection will come here. So, now this case, it is done like this, 1 when this is 1 when you have rho 1 2 is 1, here when you have rho 1 2 is minus 1. So, this bolded part here, this part, the line segment joining these 2 points and the part of the curve or the broken straight line that is between these 2 points are called the efficient frontier of the portfolio, efficient frontier. So, basically you see in both these cases the minimum value, now I can remove sigma dash and write sigma. So, in both these cases the minimum value of sigma is 0, that is there would be a value of mu or there you can have your expected returns in such a way that you have your minimum risk to be 0. But that is really not found in the real world, and so we really have to move towards a situation when you have everything between plus 1 and minus 1. So, we will have now the case when rho is lying between plus 1 and minus 1. So, now we come to the case where rho is between plus 1 and minus 1. This is the most important case to deal with. Now, you must be asking why I need to do a rho sigma study. The rho sigma study is important because you can visualize the points that are lying on what is called the efficient frontier. So, basically those are the portfolios, rather any portfolio that you can choose. You can choose any mu sigma combination that you choose there are actually a good choice as a portfolio, right. That is, either you choose mu 1 sigma 1, mu 2 sigma 2 or anything in between them. For example, once you saw a line segment, so any combination of those two. If you choose that as your optimal portfolio, that is your distribution, that will be enough, that will be a good one. So, that is the meaning of this. So, that is why this particular study is done. Here the thing will gradually become more clear when you have rho is between +1 and -1. So, what you have observed, what even if you have drawn the last part, I will just go back to the last part of it. We had two types of graphs, one for S is +1 and -1. One was a line segment like this. So, anything, so this was the only case here. Here there was another case which was like this. So, this is the point where the minimum variance is reached, and anything above that minimum variance point is called the efficient frontier. So, this is the efficient frontier. So, some people call this as the efficient frontier, but from a point of view of Pareto minimization, which I am not discussing here, this whole thing will be called the efficient frontier, which I had explained to you earlier. So, this part is sometimes just this part is called an efficient frontier because these are essentially for risk averse investor. It says that if you choose any convex combination with no short selling between these two, they are the best minimum variance portfolio for you guys. So, now we will try to look into the case when rho is between +1 and -1. So, here again I will recall that we will put mu as mu1 or sorry, I should write it as W1 mu1 plus W2 mu2, and sigma square is W1 square sigma 1 square W2 square sigma 2 square plus 2 W1 W2 rho 1 2 sigma 1 sigma 2. So, this is exactly what we had already written down. Now, again I will put W2 is equal to S and W1 equal to 1 minus S. So, W1 is 1 minus S and W2 is equal to S, where S is some real number of course. Now, I can write down mu. So, what is mu in this case? Mu here is 1 minus S mu1 plus S mu2, which can be written as mu1 plus S into mu2 minus mu1. This is a standard way of handling convex combinations. Okay. Once you have done that, you can also write down sigma square. And here is something we really need to worry about, the nature of the curve, the mu sigma curve. So, sigma square in this case would be the following. So, here is a sigma square, I just stopped the camera and wrote down this is a bigger expression. So, this is the sigma square expression. So, you have to observe that sigma square as a function of S is truly quadratic, because this term sigma 1 square plus sigma 2 square minus 2 rho sigma 1 sigma 2 can be expressed as sigma 1 square plus sigma 2 square plus 2 into 1 minus rho sigma 1 sigma 2. Now, rho is strictly less than 1, so this is strictly bigger than 0. So, hence this is truly a quadratic expression. So, let us look at the nature of this sigma square mu curve, right. We will be interested in drawing the sigma square mu curve. What is the link between sigma square and mu? Here writing the sigma would be a very difficult thing to understand how the nature would be. Let us write sigma square and mu. So, if it is there, what is the relationship? So, suppose for the time in mu2 is bigger than mu1. So, if I think for the time in mu2 is bigger than mu1, then for any S which is positive, okay, mu is positive, right. Not mu is positive means of course, when you draw this diagram mu sigma, it is very important to understand that sigma square increases in this direction, mu increases in this direction. Actually, it should be sigma mu, that would have been a better understanding of the stuff, but that is the way finance world does it, is just do it in a reverse way. So, what happens is that when mu increases, okay, if S is positive, okay, and let us consider mu1 and mu2 to be both positive for the time being, right, mu1 and mu2 to be both positive, just for the time being, it need not be. Mu1 and mu2, assume that expected return is positive. Of course, you can say that expected return is never negative. That's theoretically it could be negative, but in practice, of course, nobody would expect an expected return is going to be negative. I am expecting a loss. That's a very bad thing no investor would do. So, from an optimistic point of view, we will always have mu1 to be positive. So, when S is increasing, then mu is increasing, right. So, when mu is increasing, mu increases as S increases. Here also, as S square increases, this will increase faster than these parts, sigma square keeps on increasing. So, as mu increases, sigma square would keep on increasing. Now, you think of S to be negative. If S is negative, then this is positive, then mu is decreasing. You keep on going towards the negative side, mu will keep on decreasing, right. So, this whole mu will keep on decreasing, but here I will have the S square. As I go make S towards minus infinity, this will become larger and larger. So, as mu keeps on decreasing, when S is negative, sigma square keeps on increasing. So, there is a part when mu keeps on decreasing. So, mu keeps on decreasing, sigma. So, from here mu, from one point mu is increasing, sigma square is decreasing, and so this is the part where S is non-negative, this is the part. So, suppose this is the point from where S is actually non-negative, and then when mu increases, S increases, mu increases, S is also, sigma square is also increasing, and there is a part when S is negative, in that pit mu decreases but S increases, with some curve like this. So, mu decreases, S increases, sigma square increases. So, S is this is the point which is a turning point, that is S goes from positive to negative. So, till when S is positive and mu2 is bigger than mu1, so suppose here mu2 sigma 2, mu1 sigma 1, anyway sigma 2 is bigger than sigma 1 by, and I have assumed that mu2 is bigger than mu1. So, this is a nice explanation. So, this is a turning point, this is the point where S has become negative, this is the point from where the curve takes a different turn. So, when mu2 is bigger than mu1, so as S I am keeping on increasing, as S is a positive quantity, so S is 0, it is still mu1, it is positive. So, if S is 0, then if S is 0, the sigma square, right, if this S value is 0, then this part has to be positive. So, sigma square would always be positive, but mu1 would be some positive quantity also, right. So, when S is 0, so we can think like this, when this is the point when S becomes 0. So, between 0 it is going, and when S is 1, here I have mu2. So, when S is 1 I come here. So, as I move from 0 to 1, S from 0 to 1, I am going along this curve from mu 1 sigma 1 to mu 2 sigma 2. And what is happening is the following. So, how do I got the curve? So, for S between 0 to 1, right, S between 0 to 1, when S starts from S is 0. So, when I keep on S is increasing. Now, when I make S positive but less than 0, right, half of this. So, the whole thing keeps on decreasing, sorry, not just S positive, I made a mistake. When S is strictly bigger than 0, so here it starts. So, from 0 to 1, from here S starts to be 0. So, when S is strictly bigger than 0, it is increasing. So, as mu increases, S between S equal to S is sum for some value of S which we do not know. So, for one part you see between 0 to some part, as S keeps on increasing, mu value keeps on increasing, mu goes up. But what happens to the S value? Because S is now between 0 and 1, this thing does not keep on dominating, because S is bigger than S square. So, though it is finally positive, this value actually keeps on decreasing, the value of S keeps on decreasing. Then after some value of S, this thing dominates this part and then it goes on increasing. That is the clean idea why the curve looks like this. So, as you move from here to here, you are changing S from 0 to 1, and that is the way this curve is drawn. This is called the mean variance curve, and that is the way it looks. So, here let me just write down for you what would be the minimum S in this particular case. The minimum S is sigma 1 minus rho sigma 2, sigma 1 square plus sigma 2 square minus 2 rho 1 2 sigma 1 sigma 2. So, this is the optimal portfolio, and the risk that you are exposed to, it cannot be 0, it is a positive risk that you are exposed to. Sigma 1 sigma 2 1 minus rho square sigma 1 square. I would ask you to go home and do the calculation, 2 rho sigma 1 sigma 2. So, this is, even if sigma 1 sigma 2 is equal, does not matter, it still you will see, you will still get something. So, from here a lot of more conclusions can be drawn, but this is very important. This is a very important drawing. So, for the risk averse investor, this part is called the efficient frontier, this one, not the lower part. So, I would like you to really compute out this part and check it for yourself. You see, from this mean mu diagram, you have now found the weight and found. Of course, you now have to see, if you know, don't have to have short selling, you have to put, this is rho equal to 0, also you have to have 1 minus S mean to be greater than equal to 0. And then you will see what conditions you require on sigma 1 and sigma 2 and the relation between sigma 1, sigma 2, sigma 1 and sigma 2 and rho 1, 2, so that there is no short selling. If there is short selling, what should be the condition? So, that I would leave it to you, and I would ask my TAs to put them as an exercise in the coming future. So, with this we finish the second week, and in the next week we start with capital asset pricing model, maybe 1 class maximum or 2 class, and then we go to pricing European call options, and which will lead us finally to the Black-Scholes formula. Thank you very much.